Well, hello Internet, and welcome to my MySQL tutorial. In this tutorial, I'm going to cover about 95 to 98% of everything you will ever need to use MySQL. And I have a lot to do, so let's get into it. Okay, so this is MySQL Workbench, and you should install it whenever you get MySQL, and I'm not going to go through the whole installation process because that's pretty easy, and everything will be exactly the same on Mac, PC, Linux, anything. If you want to come in here and go and create a new user, you're just going to come in here, open up MySQL Workbench, click on Server Administration, and then you're going to have this pop up, and click on OK. Then going to have to type in your password, and then specifically, you're going to go to Accounts, Manage Users, and you're going to see all the users. The user I'm going to use in this tutorial is going to be MySQL admin, this guy right here. If you want to create a new user, just click on Add Account, and then you're going to come in here, give a username, a password, and all that stuff, and then you can go into administration roles and all of the different things that that user will be able to do. I'm just going to cut it short right there and jump right into MySQL. Okay, here I am in a terminal. Like I said, everything is exactly the same on PCs and on Linux and on Macs and everything. So this would be the command line in Windows or a terminal inside of Linux or Mac OS X. So you're just going to start it up. You might type in MySQL 5 or you might have to type in MySQL. It depends on whatever your system is set up for. And I'm just going to come in here and I'm going to log in. Like I said, this is a custom made user, and you just type in -U for the user ID and -P for the password. Type in whatever password I set up for this user, and here I am inside of MySQL. Now if I want to quit out of MySQL, I just type in quit and I'm out. You can also just press up and log back in and then type in my password again, and here I am again. Clear my scroll back. If I want to show all the databases that I have inside of my database, I just type that in, show databases, and you can see all of them pop up right there. And I'm going to try to stick with convention. So normally whenever you're typing in all of your commands in MySQL, you want to use uppercase letters. So if I want to create a database, and let's say I want to call it test3, there you go, went and created that. And we can also come in here, show databases, and you can see test3 is there on our screen. If I would want to then use that database, I'm going to try and stick with the uppercase here. I just type in test3, and there you can see that is going to be the current database I'm using. If I want to show my currently selected database, I just type in select database, and there you can see I'm using test3. And then if I want to destroy that database, just type in drop database if exists test3, show databases, and now you can see test3 is gone. And I have a link in the description for this video that has all of this listed out, and it's heavily commented. You can use it as a cheat sheet. Now in creating our database, what we have to do is, very often it makes a lot of sense to print out everything, just write it out exactly what you want to store. So what I'm going to do here is create a student database, and you can see here I have student, and we're also going to have scores for both quizzes and tests. And you can see all of the information. I'm going to have a science class, and I'm going to have an English class, and a whole bunch of other different classes as well. And I'm just going to model out exactly what I want my data to look like. Then after I model all of this out, and I give each of my students an ID, as well as test scores and all of the other things you can see right here, I can then break all of this down into tables. And we're going to go through these tables one at a time, but as you saw here, it makes a lot of sense for each of the students to have their first, last name, email, street, and all of the other different things that you see right here. And you can see down here where I have student ID, that's going to be the unique ID for each of our students. And as you're going to hear here in a moment, this is known as a primary key. I'm also going to have my classes and my tests and absences and all of the different scores also stored in different tables. And as this tutorial continues, I'm going to go over how all of these are going to be created. So we're going to come in here and we're going to create our student table. So to create our table, you just type in create table, and I'm going to call this student. Put your bracket inside of there, and then you're going to list out all of the data that you want. Now I believe that the maximum length for my first name is going to be 30 characters, so variable number of characters, and this is just an estimate. This isn't a cut in stone announcement. We're saying that we expect 30 characters, but it might go over that. If I want to guarantee that this data is entered, I'm going to type in not null, and then I'm going to do exactly the same thing for my last name. Variable number of characters that I believe is going to have a maximum size of 30, and I want to guarantee it's in the database, so not null. Then I come into my email. I'm going to, again, variable number of characters. And this is the data types that we're defining here, variable number of characters. You're going to see more here in a second. I'm going to say that I expect it to be no more than 60. But in this situation, I'm going to type in null. Maybe the person or the student doesn't have an email, or maybe we won't be able to get it whenever we want it first off. So we're going to say that that doesn't necessarily need to be filled in. Street, I'm going to say variable number of characters again, put it at 50, and I'm going to say that I must have a street address for my student. Make sure you put a comma at the end of all of these. City, not null again. State. In this situation, I know that the state is only ever going to have a maximum of 2 characters, so I'm going to actually put this in stone and say, I expect 2 characters here, and that's exactly what that says. And then if I want to put a default value inside of here, like Pennsylvania or PA, that's how we would do that. For my zip, I'm going to have a medium-sized integer, and I'm going to go over exactly why we want that in a moment. If there's no such thing as a negative zip, so I'm going to say that it's unsigned. Phone, I could just say that this is going to be numbers, but in this situation, who knows if they're going to put dashes or whatever inside of there, so I'm going to say a variable number of characters, and I think that's going to be around 20 characters, and not null again. Birth date, I'm going to mark this as a date, and not null. Like I said, I'm going to go over these data types here in a moment. Enumerated type, if I know that we're either going to have a male or a female, well, I'm going to define those very specific options by using an enumerated type like that. Let's say I also want to mark the date that they signed up for our class. I could use something called a timestamp, which is also going to give me date and time. Let's say that I also want to have cost for lunch. I don't know, I'm just making these things up. In that situation, I'm going to need decimal values, and that's going to be a float. And then the final thing we're going to define here is student ID. That's going to be a unique number, and it is going to be an integer, and we're going to mark this as unsigned, not null again. And if I want this to automatically increment every single time a new student is created, I type in auto increment, and this is going to be a primary key, which is going to allow me to have a unique ID for each of these students, which is going to help me a lot. And after I create that database, I can come in here and go show tables, and there you're going to see the student database is created. Another thing you need to do, of course, is make sure that you go and create your database, because I deleted it previously, and then say use test3, and that's the name of the database. You can change the name to whatever you want. Now, each of the students is going to have what I call a primary key, and let's just go over briefly exactly what a primary key is and some rules about them. They're going to be used to uniquely identify a row or a record, or student information in this situation. Each primary key must be unique to the row. It must be given a value when the row is created, and that value cannot be null. That original value cannot be changed, and it's probably best to auto-increment like I just showed you. Now it's time to take a little bit of time to talk about what are called atomic tables. Now, as your database increases in size, you're going to want to be able to keep everything organized. And the main reason you're going to want to do this is so you're going to be able to perform queries really quickly with your database. Now, if your tables are set up properly, your database is going to be able to crank through hundreds of thousands of bits of data in a matter of seconds. If it isn't, however, then you're going to have everything be very, very slow. So you may ask yourself, well, how do you know how to best set up your tables? Well, basically, you just need to follow a couple simple rules. Every table should focus on describing just one thing. For example, a customer table would have name, age, location, and contact information. It shouldn't contain lists of anything such as interests, job history, past addresses, products purchased, etc. None of that nonsense, just the main bit of information that you need. Then after you decide what one thing your table will describe, such as we had students, then what you need to do is decide what things you need to describe that thing. Then you're going to write out all the ways to describe that thing, and if any of those things require multiple inputs, pull them out and create a new table for them. So for example, with our students, if we had a list of past classes and past performance, we would put that in another table. Then once your table values have been broken down, we refer to these values as being atomic. However, you want to make sure that you're careful and you don't break them down to a point in which the data is harder to work with, so that you have to type in mile-long queries just to be able to get at your data. And as this tutorial continues, you're going to see exactly how I build all of these tables one by one. Some additional rules that might help you make your data a little bit more atomic, and if you can't wrap your head around all this right now, don't worry about it. We're going to give examples. But one thing you want to do is make sure that you don't have multiple columns with the same sort of information. So for example, if you wanted to include employment history for an employee database, you shouldn't create job 1, job 2, and job 3 columns. What you want to do is make a new table with that data instead. You also don't want to include multiple values in one cell. So for example, you wouldn't create a cell named jobs and then list that the person worked at McDonald's, Radio Shack, Walmart, and so forth and so on. You want to split all that out. And that brings us back to creating our tables and all of the different variable types. So you have your variable number of characters right here. You have variable number of characters here. You also saw here I have a character. Here I have a medium int. Here I have an enumerated type. Here I have a date, primary key of course, and timestamp. What do all these mean? I'm going to briefly go over all of them right now. Okay, for the numeric types, if you are only ever going to store a value between 127 to negative 128, you would use what's called a tiny int. You could also see here the minimums and maximums for small ints, medium ints, and ints in general. Here are all the string types. You have characters, which is going to be a fixed length series of characters. Variable characters, which you saw that I used a lot and whenever I created the last table, and it's going to have a variable length even though you put a number in there. That is just an estimate. And then you have blobs, which can be quite large. More numeric types, you have big integers. You can see there the minimum and maximums. Floats, which is what you're going to use with decimals, as well as doubles. Then you have your string types. You're going to have enumerated types, which is just like you saw there. Whenever you know that you're going to have a limited number of possible values like male or female, enumerated type works well. And then you have sets, which I'm actually going to skip over in this part of the tutorial, which is just going to be a list of legal possible character strings. And the main difference between an enumerated type and a set is that a set can contain multiple values, meaning that you could pick male and female, for example, if you wanted to, whenever an enumerated type can only ever have one real value. Then we have date types, as you can see there. Date is just going to be year, month, and day. You're going to have times, which is hours, minutes, and seconds, date times, timestamp, and year. Okay, so we're back in MySQL. And if you want to see a description of any of your tables that you create, you're going to type in describe and then student. And there you can see it's kind of messy. But if I shrink it down in size, you're going to see that everything is listed out there exactly as we typed it out. So how exactly do you go and enter values inside of here? What we're going to do is we're going to insert student information. You just type in insert into and the table you want to insert that data into. And then you're going to type out values. And you can skip around onto different lines if you'd like. And here, I'm going to type in a student name, Dale. And you're going to want to type this in an exact order that you set up the database. So we had first name, we had last name, and then we had email address. And if you're working with characters, you're going to want to make sure that you surround them with quotes. And then we can type in our address. And you can see here I can type in, bounce around as much as I want. And my city and my state. Zip code, which is an integer, so we don't have to put quotes around it. Phone number, which is a character. We have to put quotes around that. You could also use double quotes if you like that for our birth date. Mail. If you want to get the current time, this is the information on when this information was entered into the database. You just type in now with the two brackets there, and that's going to give you that. And the amount they're going to be charged for lunch. And then null is going to represent the primary key. It's going to automatically increment itself. And there you can see it. And there you can see I went and filled in a whole bunch of other student information just like we did before and clear that out of there. If we then want to show all that data, we're going to go select and we're going to put star inside of here that says basically we want everything. And then we're going to say what table we want to pull that information from. And there you can see it's kind of messy again. If I shrink it down now, you're going to see all the student information entered in there. I have to shrink it down quite a bit just to be able to fit it all in there, but you can see the first name, last name, email, street, city, state, zip, phone numbers, birth date, sex, date entered, and you can also see how those are changing and exactly what the timestamp looks like, lunch cost, and the student ID, and you can see those auto-incremented. Okay, the next table we're going to create is going to be class, which is going to have a class ID for each of the possible classes. As you saw right here, we had science. We're also going to have English and a whole bunch of other different things. And then this class ID is going to be put inside of the test area, and that's how we're going to be able to keep track of everything. I'm going to keep everything normalized, like I said before, or atomic, by separating out everything that doesn't need to be there. And we're going to have class be in its own table because there's no need to type in science multiple different times here or English or whatever inside of the test area. So to create this table, we're going to go create table, and we're going to call it class, just like we defined there. And each of these is going to have a name, and I'm going to say variable number of characters no longer than 30, and not null, of course. We want to make sure we have something in each one of those. And then we're going to need a primary key for this. Unsigned, not null, just like before. Auto increment, so we don't need to worry about it. Primary key, of course. Close that off. And show tables, you can see class was created. Then I can just paste this in here, another insert, save myself some time. You can see English and all those other different things, and null again is going to allow this to auto increment. And there you can see that's been created. And if I want to see everything, select again, star for everything, from, class, and there you can see they're all listed. If I want to create my test table, create table, test. Inside of that, for each of these tests, we're going to have a date and date type, of course, and not null. Remember, we had an enumerated type that was either a test or a quiz, so we're going to create that. Not null again. Class ID is going to link out to the table that we just created here. And like I said before, this is called a foreign key, which I'm going to talk about in a second. And then test ID, which is going to be the primary key for this guy. Again, int, unsigned, not null. And every primary key is going to look like this. Primary key. Boom. And you can, of course, use lowercase letters, and there you can see all of those are created. Now, as I said a second ago, a class ID, like we created in the test table, is known as a foreign key. And what they're used to do is make references to primary keys of other tables. So, class ID inside of the test table is a foreign key that references a primary key over in the class table. And to give you another example, let's say we had a customer and a city table. If the city table had a column which listed the unique primary keys for all the different customers, that primary key listing in the city table would be considered a foreign key, or just like you saw previously with the testers and the classes. Now, the foreign key can have a different name from the primary key, but very often it makes sense to keep them the same. The value of a foreign key can have a value of null. However, that wouldn't be advantageous most of the time, but it's possible, most definitely. And a foreign key does not need to be unique. But that's quite obvious because we could have multiple different people in a science class taking a test. So you would have science numerous different times inside of there to represent the foreign key. And of course, they wouldn't be unique. Back over in MySQL, and now let's create our score table. Create table, score, student ID, int, unsigned, not null, event ID, which is going to represent the test that was taken. And I'm going to go back in here as I show you other different things and change names and so forth inside of these. We're going to have our score, which is going to be an int because these are all small numbers. And then what I'm going to do is I'm going to combine the event and student ID to make sure that we don't have duplications in regards to scores. And it's also going to make it quite easy to change scores later on. So I'm going to create a primary key, and if I want to use the event ID and the student ID to make sure they're unique, that's exactly how you do that. And there, that's created. And once again, the reason why we're combining the event ID and the student ID is because in the scores table, we're going to have multiple different tests that are going to be taken by each of the different students, so that's not unique. And also the student IDs, because they're going to be taking multiple tests, are also not going to be unique. However, if we combine the two of them together, that is going to be unique. Last table we want to create here is the absence table, which we're going to use to make sure that the students are going to be able to take tests that they missed. And it's going to have a student ID inside of it. It's going to be unsigned, not null. It's going to have the date of the absence, date data type, not null again. And once again, we're going to create a primary key that is going to combine the student ID because students could have multiple absences, so we have to figure that out. And date, since they can only miss one date, there we go. Now we have a unique primary key. And there you can see all those are created. Now, if we want to come in here to the test area and describe that. Now, let's say that we wanted to have multiple different types of quizzes and multiple different types of tests, meaning that there would be different types of, and different numbers of questions inside of them. How exactly would we go in here and add in a new row that's going to have the maximum score for each of these tests and quizzes? Well, we're going to go in here and we're going to type in alter table. The one we want to alter is called test. And then if we want to add a new row of data inside of this, we're going to go add. And let's say that I want this to be called max score. And then I'm going to define the data types, not null. And if I also want to put it after type, for example, to keep it away from the different keys, I can type in after type. And there you go. And if we go describe test, you're going to see max scores in there. Another way to enter data inside of these, let's say I want to add in some test data. Well, let's go and put that on the screen so we can see exactly what's going on here. We can also go insert into test and values. And then we can put all this in here at one time. So let's say that the test is in 2014, 8, 25, and it's a quiz. And the maximum score is 15, and the class ID in this situation is going to be the first, and then we're going to make sure you put a comma in there, and then you're going to put null, and then you're going to put a comma after that, and then put in all that other additional data, and there you go. That's how you would be able to enter all of those different types of data all in one query inside of MySQL. And then we can of course see all of them, select from, test, and there you can see them all in one place. Now, how exactly would you go in here and change the name for a row? So let's say we go into, we want to see what's in score, and we decide that event ID doesn't really make any sense, and we would prefer to have test ID inside of there. How do we go in and change that? You're going to go alter again. As you're going to see, use the same commands over and over again. And then you're going to type in score, which is the table you want to change, and then you're going to type in change. And if you want to change event ID to test ID instead, you're then going to have to define the data type for our new test ID, unsigned and not null. You're then going to be able to go describe score and see that it's been changed from event ID to test ID. I'm then going to enter in all my score data, and you can see right here where I commented this one line. This is how you put a single line comment inside of your queries. You can see here insert into score values, and I have all that there just to save time. And you can see that I updated that. If I also want to come in here and put some data in the absence, there you can see that. And it's often a good idea to use describe to be able to see exactly the order you should put your data in. And you can see there I'm using insert command again, and there are all of my absences for all the different students, or you can see right there. Now, to list all of this data out, you're not always going to use the star command, which is going to list out everything. So let's say with the student database, I just want first name, and you could also come in here, nothing's case sensitive, so you could go first name or last name, whatever you want. Then you just come in just like before and go student. And that's going to list out all of our student names. You can also see here, however, that whatever you type in here for first name is going to show up there and last name there. We're going to correct that in a moment. Now, another thing that's sort of bothering me about this is if we show our tables, you're going to see everything here is absence, class, score, student, and tests. Well, I kind of would prefer these to be plural. So that's going to mean I need to go in and rename my table. And I'm going to rename all of them instead of just some of them. So we're going to go into absence, and I could just do one or I could do multiple ones. And we're going to change this to absences, class to classes, score to scores, and then test to tests. And if we then come in here, show tables, you're going to see all of those are plural now. So let's go in and let's say that we just want to be able to select the first name, last name, and the state from our students database, from students. And this is where comes in. Where is used when you want to limit your data. So I'm going to type in state, and let's say I just want all students that are from Washington. And there you go. And we could also do more than that, way more than that. Say I want to get first name, last name, and birth date from students. And if I just want the people that are born after 1965, I can specifically get just the year from the date of birth part. And I just type in birth date and greater than or equal to 1965. And there you can see that data. And of course, you're going to be able to compare all of these using equals to, greater than, less than, greater than or equal to, less than or equal to, or not equal to. I could also go in there and get the month. So I'll get first name, last name, and birth date from students, and it doesn't matter that the from has a lowercase m. And let's say where, and if I want to just get the month, like let's say we're looking for birth dates or something for the month, I don't know. Just type in month, birth date is equal to 2, or another thing we could use is an or statement to put in multiple conditions. Or state is equal to California. So this is going to match if they were born in February or they were born in the state of California. And there you can see. And you're going to be able to combine these conditions either using or, as you just saw, and another guy you can use is not. And instead of or, if you wanted to put in here two of those guys, or for and, you want to put in and, you could do that. And for not, another replacement for that is an exclamation mark, which I'm going to show you here in examples. And let's make another query here that's a little bit more complicated that uses those logical operators I just showed you. So let's go last name, state, birth date from students again. And let's say we want all the students that have a birthday that is greater than or equal to 12. And we could put and inside of there, or we could put and inside of there like that. Put brackets here if we want to combine these guys, or they're born in the state of California, or put that in there, or put or, doesn't matter. I'm going to put that just to show you they're the same. Their state they were born in was Nevada. And there you can see all those matches. Another weird guy is null. If you want to check if a value is null, you cannot use the greater than or equal to or any of those different things. What you have to use is either is not null or is null. And select, so let's say last name from students, And if we wanted to check if a last name was not entered at all, we would go, is it null? And that would list every single last name student that didn't have a value in there. Or we would come in and go, is not null. And if we go, is not null, it's going to list all of them because all of them have last names. Another thing we can do is decide how our data is going to be ordered inside of MySQL. So let's say first and last names from the students table. We want to order them by last name. There you can see all of them are in alphabetical order now. And if you wanted to put them in reverse alphabetical order, you would just type in order by, and whatever your column name is, followed by DSC. That's going to be reverse alphabetical order. You could also combine those. So let's say you want first, last name, and state from students. And the most important thing is to order by state. And let's just do it in descending order. And secondly, you wanted last name in alphabetical order, which is ASC. And there you can see they went and had all the states put in the order, but it made sure that this was in alphabetical order like that. Just another weird query. If you want to limit the amount of data that you're going to get to say the first 5 results, just type in limit 5. If you then wanted to get the next 5, you would just come in here where the 5 part is and type in 5 through 10, and there you can see you get the next 5. Now these guys are kind of messy where you see first name and last name, so there's a couple different ways that we can clean that up and also clean this data up so that the names are not divided on the screen. We're going to use concat, which is going to allow us to combine data. So let's say we wanted to get the first name and then we wanted to have the last name as well, all in the same area, but we want the title at the top to be just name. We're going to type in as and name like that. And let's say we wanted to get the city and the state and combine those all into one block as well. City, state, and let's say we want this to be hometown. And we want that from students. And there you can see everything's listed and you can see names right here. That's because of this as right there. And hometown's there because of that right there. And all this data is combined because we use the concat command. Another thing we can do is use like, which is going to allow us to get data that fits certain constraints. So let's go select and let's say we wanted our last name and first name from students where, and let's say that we wanted everybody that's first name began with the letter D. We would say like D, and then we would put a % inside of there. Or last name like, and let's say we wanted everybody that had a last name that ended with the letter N. There you can see all those. And this % basically matches any sequence of characters, so that's what it's used for. Another thing we can do with like is we could use underscores, which are going to match any single character. So let's say we wanted a 4-letter name that ended with the letter Y. Name from students, where first name, there's like again. And we use underscore, that represents 1 character. So we want 3 characters and an ending with Y. And there you can see those matches. Now let's say in our results, we only want to show something once. We would use distinct in that situation. So let's say we wanted a listing of states from students, and we want to order by state. So we're going to see every single state that every single student's from, but we're only going to see it one time. There you can see that's what distinct does. It only gives us a result one time to avoid duplication. If we then wanted to go in and count the number of students from each of those states, we would use count, and then we would use distinct to only show our state one time from students again. So you can see that our students come from only 8 distinct states. We could also use count to come in and count the total number of students that we have in our class. Select count from students. See, we have a total of 10 students. Could also use count to go in and count the number of boys in the class. Count all. So that's going to give us all the students, and then we're going to say from students, and then we're going to use where to issue our conditions. You see we have 6 boys in each of the class, or 6 males. Another thing we could do is group our data. So select, and let's say we wanted sex and the count for each of the sexes, sex types from students. And then let's say we want to group them by sex. So the thing that's going to be different between the 2 of these is it's either going to be male or female. And there you can see we have 6 males and 4 females. Do a little bit more with group by. So let's say we want, select the month, birth date, and let's change the column name for this to month. And we want to count all of those different birthday months from students, and we want to group by month, and that's a reference to this month up here. That's what that month is. And then we want to order by month as well, and there you can see. for each of these months, the number of students that were born in those months. Another thing we can do is narrow our query results after the query has been issued using a command called allow. So we're going to say that we want the state, and we want to count the number of states, and we're going to give this the name amount. We're going to pull this data from students, and we're going to group by the state. We're only going to list a state if more than one student is from it. So that's what having allows you to do. So we're going to say having an amount greater than 1. And there you can say it lists California and Washington because 2 students in both situations were born there. It's also going to be a whole bunch of math functions you're going to be able to do. So let's say that we want, let's put these all in separate lines. So let's have our test ID as test. And let's say that we want to get the minimum score on that test. Score. Give this the name as min. Get our max score. Get the range of scores. Did the max minus the min, and there's all of them, including sum and the average, and we're going to be pulling that from the scores table, and we're going to group by test ID, and there you can see all of those. Now you can see a whole bunch of the different numeric functions that are available in MySQL. I'm not going to give examples of every single one of them, but as you can see, we can get an absolute number or an absolute value for a variable. There's all the different trigonometric functions. You can get average, like I just showed, ceiling, which is going to return the smallest number, not less than whatever it's passed to. You're going to see count, like we've seen multiple different times. You also have the option to get degrees. Going to be able to use exponents. You're going to get floor, which is going to return the largest number not greater than the value passed to it. The logarithm function, max min, modulus, which is going to return the remainder of a division. You can get the value of pi. You're going to be able to make calculations based off of power, radians. You're going to be able to get random numbers. You're going to be able to round. You're going to get square root. You're going to have standard deviation, sum like we saw before, and you're going to be able to truncate. So you can play around with those different mathematical functions on your own. And let's go in here and just do a couple other different things. Let's take a look at absences. Everybody that has an absence from our classes, and there they are. Let's say that I wanted to come in here and have a student that missed a test go in and retake that test and get a score. So we're going to look in the scores table here. Now what I'm going to do is I'm going to go select, and I'm going to get student ID and a test ID just to show me what's going on here from scores. And I'm going to look up the specific student ID that is equal to 6. Because student ID right here missed that test, so I want that student to take that test. You can see them right here, and you can see they missed test number 3. Now I go and I give them test number 3, and they go and take it, and they get a result. Now I'm going to go in here and actually change the values for that, and to do so I'm just going to type in 6, which is their ID, 3, which is the test ID, and 24, which is going to be their score. And I can come in here, and I'll now see that they actually took that test. Well, now what I'm going to want to do, because the absence is still going to show up there, is go in and remove that. So if I want to remove data from my table, I just go delete from, and the absences, where, and in my condition, student ID is equal to 6. And there you can see, select everything from absences, and there you can see it's gone. Now let's say that since we're looking at absences here, we might, and let's look at it close. Let's say that we would like to have true or false inside of here in regards to whether they took the test or not. So let's say we wanted to keep track of all absences and just wanted to put true or false if they took the test or needed to take the test or whatever inside of here. Well, we're going to use alter again, and table, absences. We want to add a column. Let's call it test taken, and it's only ever going to have either a true or false inside of here, a character, and let's just put not null, give it a default value of F, and let's say that we want it to come after the student ID. And like I said, you could put before in there as well. And it would be useful to be able to spell absences right. So instead of absences, absences. And there you can say that's changed. And describe is going to show the test taken's in there. Well, now what if we, in using some logic, we realize, well, it's only ever going to have a value of true or false, so this should actually be a enumerated type. So let's go in there and let's fix that. And once again, to change the data type for our table, we're going to go alter table, absences, modify, column, and test taken is the guy we want to change. And we want to change it to an enumerated type that's only ever going to have a value of true or a value of false. And it's going to be not null again, and it's going to have a default value of F that they did not take it. And there you can see that's fixed. And then let's say that we come in here and we say, you know what, let's not have that at all. As you can probably tell, I'm just messing around here. And we decide that we don't even want test taken in there. We can go alter table, absences, and drop column is going to allow us to delete a column, and test taken will be deleted, and there you can see it has been. Now I'm going to go in and show all of my scores where the student ID is equal to 4. Now let's say I want to update a score. Maybe a score was entered incorrectly. So we would go update scores, and I'm going to set the score equal to 25, where, and the condition here is going to be the student ID is equal to 4, and the test ID is equal to 3. And then if we pull that back up again, you're going to see that that's been changed. Another thing that's useful is a command called between, and what between is going to allow us to do is find matches between a minimum and maximum. So let's say we wanted to find the first, last name, and birth date for any student that was born between 1960 and 1970. There is between, and there you can see that's exactly what it did for us. Another useful command is to be able to go in here and find matches based off of a list. So, and one way to do that is to use the command in. So what we're going to say is we want first and last names in which the first name is in our list. So either Bobby, Lucy, or Andy, and it grabbed it for us there. And in is a great way to narrow results based off of a predefined list of possible options. And this brings us to actually joining data together. Now, if you want to combine data from multiple different tables, you can perform what is called a join. And a join works by matching up common data like I'm going to show you right now. So let's say that I wanted to get the student ID, date, score, and max score on a test. Well, this data all comes from two different tables. So if I want to join two different tables, I'm going to say from both tests and scores, don't put that comma there, where date, so I'm going to get all of the student IDs, data, scores, and max scores for the date of 2014, 25th. Then what I'm going to have to do is decide on how these two tables are going to join together. Well, as we can see right here with our different tables that we created, we have our tests table right here and our scores table right here. Well, we're going to have to find something that is like, that they both have, so that we can join them together. I actually had to come in here and correct this. The two things that they both have, being test and score, is test ID. So we're going to join these two tables together by pointing out those two things that are equal. And to do so, we're going to go and test ID is equal to scores test ID. And there you can see we got exactly what we wanted. So you can see it's quite easy to join two different tables in this situation. All we need to do is find like data like we did right there. Now, whenever you're joining these different tables together and different table data, it's often going to be advantageous to precede each of the pieces of data you want with the table's name, so you're not going to get confused. So we're going to go scores, student ID, tests, date, scores, the score, tests, max score, and then we're going to say the two different tables we want to join, the condition, and then and test ID is equal to scores dot test ID. And there you can see the same data. So how exactly would we go in and join three tables, for example? Let's do a big giant thing. Let's go select concat and students first name and students last name as name. Let's get test date, scores, the score. Say we want to get the max score as well, and let's say we want to pull this data from three different tables, which is going to be from tests, scores, and the students tables. And we want data in the situation where the date is going to be equal to 2014, and then we're going to have to just use multiple different conditions, and we're going to have to match up like data between the different tables. So test ID is going to be in the tests table, and it's also going to be in the scores table. And then we'll have to match up the last one, which is scores, student ID is equal to students, student ID. And there you can see all that information. I'll just go through a couple other different commands. Let's say if we wanted to come in here and list the number of absences per student. Well, we're going to put in our student ID, we're going to put in the first and last name, and then we're going to count the number of absences from the absences table. We would then want to group by that specific piece of data that we're going to want to get, otherwise we're just going to get one result. And in this situation, you're going to see a quick way to get the total number of absences with each student name. Another way to do a join, if we want to make sure that we include all information from the table listed on the left side of the screen, even if it doesn't exist in the table that we're combining it with, is to use what is called a left join. So let's go select first and last name, and then let's say that we want to count the total number of absences. Once again, we're going to be using this because we want to list the students that have absences and the students that do not have absences. That's why we're going to use a left join. And to use it, you're going to say from students. You want to make sure you list all the students' names, whether they have absences or not, and the other table you want to join to. And then you're going to put in your condition, or the two things that are the same between these tables. So I'm going to say the student IDs are equal. And then finally, we're going to group these by the student IDs. And there you can see we're listing the absences even if they are 0, and that is all occurring because of the left join that we just did. And the final join we're going to cover here are what are called inner joins. And an inner join just gets all the rows of data from both of the tables and puts those together. So let's just do something quick. Student's first name, student's last name, test ID, score. And we're going to use the students table and do a complete join between the students and the scores table with an inner join. And then your two things that these tables have in common are going to be defined, which is going to be the student ID is equal to the scores student ID. And the condition in this situation is we want to list all the scores that are less than or equal to 15. And let's say we want to also order them by scores test ID. And there you go. Every single score. And this is basically just going to give us all of our quiz data for every single quiz that was taken by every single student. Okay guys, so that's a lot of information on MySQL. Please leave a comment if you watched the whole thing. I'd be excited to see that. So please leave your questions and comments below. Otherwise, till next time.